Hey, welcome to the chemistry lab. I know, this doesn't really look like a regular chemistry lab, but trust me, we are going to perform some really interesting experiments in here. So don your virtual lab coats and safety goggles. So you must have heard of these two words, double salts and coordination complexes. Back in high school personally, I had a hard time trying to wrap my head around this topic. So don't worry, I won't let you go through the same torment. But bear with me for the theory part of it. It'll fetch you a couple of easy marks. So a double salt is just like any salt. It is made up of cations and anions. The only trick here is that there can be multiple cations and anions. Like for example Mohr's salt, which is ferrous ammonium sulfate hexahydrate. That is NH4 whole twice Fe SO4 whole twice 6H2O. Now you can see that there is a dot between the water and the rest of the chemical species. That is because the bond between the water and the rest of the chemical species is not of chemical nature. It is a physical bond. On the other hand, coordination complexes are, as the name suggests, a little bit more complex. The complex, the chemical, is made up of two parts. The coordination sphere, which is the stuff inside the square brackets, and then there is the ionization sphere, which is nothing but a bunch of counter ions which balance the charge of the overall complex. For example, potassium ferrocyanide, K4FeCN whole 6. Now, both of these chemicals have iron, that is Fe. You can see it in the formula. Let's check how they look. Here are the two chemicals right in front of you. The pale green compound is your Mohr's salt or ferrous ammonium sulfate hexahydrate. The pale yellow compound is then of course your potassium ferrocyanide. We are going to carry out a very simple experiment using very easily available chemicals. All we need for this experiment are the two chemicals and aqueous sodium hydroxide. Yeah, just sodium hydroxide, simple NaOH. Concentration doesn't really matter. You can take the dilute NaOH which is kept on the personal racks. We are going to carry out a qualitative analysis of ferrous or Fe2 plus ions. So the exact concentration and stoichiometry don't really count, and that's why I just love it. Anyways, the reactions are very simple. We take the two chemicals, Mohr's salt and K4FeCN6, which is potassium ferrocyanide, which we want to analyze. We dissolve them in water in separate beakers of course, or as we say, we hydrolyze them. Upon hydrolysis, we get the constituent ions. We don't really care much about what the anions are as long as they don't interfere in the further reactions. Assuming that is so, upon hydrolysis, we get the cations and the anions. Once the chemicals have hydrolyzed, we pour the aqueous sodium hydroxide. If ferrous ions are present, they will react with the sodium hydroxide and form a dirty green precipitate of ferrous hydroxide, that is FeOH whole twice, and sodium ions will be released in the solution. Let's get to the experimental part now. Let's take the potassium ferrocyanide, the pale yellow compound, in a test tube. Now add distilled water to the test tube and shake well till you get a pale yellow solution. Now let me give you a warning. You will not get this bright color solution unless you dissolve a large amount of the solute, which is completely unnecessary. Even a very dilute solution which will give you the same result, so no point wasting precious chemicals. This is just for your visualization. So once we get a homogeneous solution, add the aqueous NaOH. No need for caution, no measurements, just add it anyway. As you can see, there is no change of color. We can conclude that ferrous ions are absent in the solution. Now let's perform the same activity for the Mohr's salt. We take the Mohr's salt, the pale green compound, in a test tube. We add distilled water and shake well till you get a homogeneous pale green solution. Again, here as well, you don't get this bright of a solution unless we take a large amount of solute, which is totally unnecessary. This is just for your depiction purposes. Now pour the NaOH to the homogeneous solution. As you can see over here, we observe a dirty green precipitate on the top. If you pour more NaOH, you will see more of the dirty green precipitate. This indicates the formation of ferrous hydroxide. Thus, we can confirm that ferrous ions are present in the solution. So, what do we conclude from this experiment? In coordination complexes like potassium ferrocyanide, the ions or molecules inside the coordination sphere cannot dissociate in their aqueous solutions. Like how we saw potassium ferrocyanide gave negative test for ferrous ions despite having iron in the +2 oxidation state. In double salts, on the other hand, like Mohr's salt, all constituent ions can dissociate in the aqueous solution, like how we got the dirty green precipitate confirming the presence of ferrous ions in the Mohr's salt solution. I hope now that you have a better understanding of the differences between coordination complexes and double salts. If this video helped you understand the concept better, like the video, share it with your friends, and put your thoughts in the comments down below. Until next time, see you.